Hello, my name is Ty Gallagher, and I'll be telling you a little bit about my Webpage2Wordcloud project. So, one of the main goals of this project was being able to create a graphically driven program that takes a user input of a web page and uses that to create a word cloud out of it. So, one thing you may be asking is, why word clouds? Well, one of the main goals of this project is to showcase the relative strengths of Python over some other programming languages. It's also something that a lot of people are familiar with, even if just tangentially. Most people have probably seen a word cloud at some point before. Even if it isn't ringing a bell right now, once you actually see one on screen, you'll probably recognize it. And another great thing about this project is that it allowed me to be very flexible with the way that it's designed. This gave me some great freedom in being able to make it as complex or as simple as I really wanted it to be. And lastly, is that the problem of the word cloud is one that's very specific. It's also pretty difficult to solve the first time that you're looking at it, but it also doesn't have a huge amount of usefulness outside of the one specific thing. It's not a great data metric, it's not anything especially useful, just something nice to kind of look at. So, stepping back just a little bit, part of what I wanted to show was the strength of Python. And it's hard to argue with one of the biggest strengths being the size and openness of the Python community. It has one of the largest communities out of any programming language that I'm aware of, at least. And because of that, it has a huge breadth and depth of tools that are available for people to use. So even something really specific and not super useful like the word cloud has a package out there that is ready to go right out of the box. So the main package that I use to make this program is called word_cloud. Basically, what this does is it takes any string that you put into it, it looks at the frequency of all the words in that string, and it creates images for each of the major ones and tries to put them together in a way where they fit as closely together and leave as little blank space as possible. So that right there solves pretty much the main issue with this program. Coming off of that, one of the other packages that I used, which is very important, is called Beautiful Soup. This is a pretty popular package, unlike word cloud. It's used by some sites like Reddit to generate the content previews whenever you want to preview something that's on their site, like the little hover over thing that you can get. This basically takes in an HTML page and it parses it down to more user-friendly pieces. So this is really like a toolkit, and this is more of where I came into the project than the actual word cloud portion. So for anyone who's not familiar with HTML, this is just a small example of what your typical HTML document looks like. You have a couple of tags, which is going to be like the HTML here and the body down here. Then you have the matching closing tags down here. So basically everything in between here is contained within the HTML and the body tags. There's also a little bit in here. This is H1, which stands for heading 1, and P, which stands for paragraph. So part of what Beautiful Soup is able to do is you can have it look for specific either sets of tags or just tags themselves. And it will grab all the text that's in between that. So for instance, I could tell it that I only want things that are in the body and in headings. And it'll come in and it'll just grab this little text right here. That was great because I could just figure out by looking around at different websites what the common order of tags are for websites to put the text that we want to grab in. So I basically use that toolkit to generate one big string that we'll use to make our word cloud later. Now there's a couple of other pieces that play a critical role in here as well. Probably the most important one is the request library. So a request is how we actually reach out and grab the HTML page from the website. It'll download it and it'll put it into a readable form for Python to use. Then we also have matplotlib. Now matplotlib is generally used for some data processing, displaying graphs, some useful metrics. But in this case it plays a relatively minor role in that it just is used to display the actual word cloud on the screen. And lastly we have tkinter, which I'm not 100% sure that's how it's pronounced, but this is basically a really big package that has a lot of useful features in it, but they're all centered around creating a graphical user interface for us to interact with. So just a quick review to go over everything. In order to make this program work, what we first have to do is we have to create the window, which is going to contain everything that the user will interact with in order to get the word cloud working. Then we fill it with all the different widgets to create the options menus, the buttons that we need to press in order to get it to run, the user input fields, all that. We take in all the user input from the page whenever they press the button. We get the word or the HTML file from the web page that we're given. We parse it down into a single usable string. We create the word cloud and we display the word cloud. There's also an option to save it within the program if you desire. So with that, let's go ahead and actually jump into it here. So over here we have my idle editor. This is actually running Python 3.7. I don't have any reason to believe that it would not work on 3.6, but this just happened to be the version that I installed on my environment. So if we go in here and press F5, it'll give us the actual program here. So in here we have a couple of different things. We've got the input URL. So let's grab something like Amazon, and we can come back in here and paste that. Then we have a bunch of different options in here. The max words, basically all it does is it changes the number of words that can appear in the word cloud at a maximum. It's not necessarily the number that are going to be there, but it's the very most that it will ever allow in there. Now this is probably a little bit big. We can lower it down to like 66 and still be fine. Now these over here both control the resolution of the final product. Personally, I found that it looks best if it's kind of rectangular, so I generally try and match these up pretty close. And then frequency scaling is probably the least self-explanatory of all the sliders in this menu. Frequency scaling, essentially what it does is it tells the word cloud package how precise we want it to be with the size of our words versus their frequency in the chart. So we've put it all the way up to 1.0. What's going to happen is if a word in the word cloud appears twice as often as another word, then the first word will be twice as big as the second one. By lowering it down to 0.5, we give the package a little bit more flexibility in what it's doing, and generally that makes things look a little bit nicer while still being mostly accurate to the scale. So let's go ahead and we'll hit the button here. So this is just a sample of some of the words that appear in the Amazon homepage. Now, one thing to note is that it does not work for things that are inside of images. So things like this deals won't really pop up in there. So Amazon is probably actually not the greatest example, but if we go to something like CNN.com, we can use their web page and it should work a little bit more accurately. Maybe not perfect, but we'll go ahead and we'll do another word cloud. So you can see this one is quite a bit fuller than the one from Amazon. And something kind of interesting about the way that Wordcloudify works is that it basically tries to do things through sort of trial and error method. It'll find like the biggest word first, the one that's used the most often, and then it'll try and fit different things around it, and it'll move things around in different ways every time, and it's sort of random. So you end up with these different results for the same input. So the last feature that we have on here is the saving feature. So if you want to actually save one of these word clouds as a figure, or an image rather, you can go in here and you can type a file name like look at me. You hit save, you hit the Wordcloudify button, and it'll give you this little dialog box to make sure that you're certain that you want to save this file. So you can hit yes, it will generate the figure here, and then if I open up my file browser, you can see right in here there's look at me plot, and it will open that up, and they're exactly the same. It's actually even a little bit better quality inside of this PNG file here because the PNG allows for a larger resolution than the matplotlib. And that just about wraps things up. If you have any questions, feel free to shoot me an email or a message on Blackboard. And if you're interested in looking at any of the source code, you can go online to github.com, followed by / my username and / the project name. With that, thank you all for watching. Good luck.